So let's make a line that passes through these points now. So I think the first thing that's a little different from the last problem is we don't know what the slope is. We need to find the slope between these 2 points. So I'm going to say slope. I'm going to remind myself it's change in y over change in x. And I really like to just think about slope as change in y over change in x. If you're familiar with using this formula, this really is just the change in y over change in x. So I don't like to think about the formula because that's exactly what the formula is. It's up to you. Change is, of course, the subtract part. So, okay, let's figure out the change in the y's. It'd be a really good exercise for you to just think about how far apart this y is from this one. And they're clearly 8 apart. If we plug into the formula, we're going to get 8 as long as we do it correctly. So I'm going to say that one is how far away from that one, the minus meaning change or how far away. So that's going to be 5 plus 3, which is the 8 that we discussed. Okay, so then we're going to do the same thing with the x's. Clearly negative 2 is 4 away from 2, but if you plug it into the formula, it looks like this. 2 minus a negative 2, that becomes plus. Oh, you get 4. So the slope here is 4. I like to circle it because that's one of the 2 ingredients I need for my line. Now I have a slope and I have 2 points. Since I used both points to find the slope, if I put it through either one now, I'll get my line. It'll go through both. So you might be wanting to use point slope again, and I could, but I'm going to, just for the sake of argument, use the other one because I know a lot of you guys especially have worked with mx plus b. So let's just do it that way this time. So we've got mx plus b. We know the slope is 2, so I'm going to put that in. And we know we need to make it go through a point. So either one we can pick. I like to pick the one with positives usually. So the y-coordinate of that is 2, and the x-coordinate was 5, excuse me. The x-coordinate is 2. And we've still got our plus b hanging out here that we need to find. So now let's solve for it. So that's 4 equals 5 plus b. So clearly b is 1. I have both ingredients now for my line. I'm going to put them together into line form. So 2x plus 1 is my line. And now I can come over here and graph it if I like. And say the y-intercept is 1. That's the launch pad. And I want to go up 2. That's really 2 over 1, right? So up 2 over 1. There's my other point. And there's my line. And if you don't believe that it goes through both of these 2 points, I guess you'll have to use graph paper and be careful. But at 1, we can see that it's at 3. So at 2, it's going to rise another 2 and go over 1. That's clearly going to be at 5. So this one's a check mark. You could trace it back down if you wanted to see if it went through this one. Okay. So there's an example of a really important problem, which is pretty simple, and you should be able to do it. So now let's create a line that suits another purpose. It says create a line which is parallel to the line, and you can see this time I've used the notation f of x. We're going to be using f of x as we study our library of functions theme this year in Algebra 2 quite a lot more than y, I think. So f of x and y are, of course, interchangeable names. The standard name for a function. This just really means that it's a function. So we'll get to studying functions and what it is to be a function and reviewing that another day. Anyway, so we've got another line and we're supposed to be parallel to it. So what does it mean to be parallel? I think it means that you don't touch, right? Something like that or like this. Any of those kinds of lines are parallel. All right, so I think that what it means to be parallel, which sometimes you'll see with this symbol, you might see this instead of the word parallel. What's that really mean? Is it means that the slopes are the same. So same slope. So you just really need to identify the slope of the old line here, which is -6. So our new line is going to have a parallel slope. There's nice notation for that, of -6. So we've got a slope and a point that we want to go through. So I'm going to go ahead and use point slope form. So I'm going to go y minus, want it to go through -3 for the y, equals the slope x minus, and I want it to go through 7. There you go. So you just need to simplify if you want to graph it. I'll just go ahead and do that pretty quickly here. Looks like I have a cat in the background. You'll have to excuse that cat. So we're going to have -6x. Oh, I need to distribute. I'll show you that just in case you forgot what I'm doing. Negative times negative is positive, so that's going to be 42, and we'll subtract our 3 to the other side, right? So I kind of did everything all at once there. Hopefully you're comfortable with that. So 42 minus 3 is positive 39. So this guy would start at 39 on the y-axis and go down 6 over 1. I think I'm just going to not graph it this time. You can do that. Let's have a look at a fourth one here. Example 4. Alright, so this time we want to be perpendicular. So another symbol sometimes you'll see for perpendicular is this. But I wrote out the word this time. So we've got an old line. I'm going to make a new one that's perpendicular to it. So what does it mean to be perpendicular? I usually ask my class at this point, so you might want to think about what it means. I don't think I want to use the same slope because perpendicular lines want to look like this, right, with a right angle in between. So the slope that's going to be perpendicular slope, you want to remember the words opposite, reciprocal. That should just be something that comes to mind immediately whenever you hear the word perpendicular from now on, pretty much. So our perpendicular slope is going to be opposite, so instead of negative, it's going to be positive, and we need to flip it. Instead of 7/4, it's going to be 4/7. Headache, go away. Jeez. Cat problems all the time in this house. Anyway, alright, so we could do this one with point slope again, and I could do it just like the other problem. I'm going to go back to mx plus b form just to show you guys that way in case you prefer it. So I'll write down mx plus b, and we'll plug in our ingredients. So we know that the slope was going to be 4/7, right? Alright, and then we wanted to have it go through y of -6, so -6. And we wanted the x to be 14, right? Okay, so I'll put that right there. And we don't know what b is. We're going to solve for it. So let's see, -6. 14 over 7, sweet, that's 2. So that's 8. So it looks like we just need to subtract that 8 to the other side. I'll show my work this time. Man, this cat is relentless. Okay, so that gives me b equals, looks like -14. So I've got that ingredient, and I can put them together to come up with my line. So I'll have y equals 4/7 x minus 14. We'll graph this one just since we didn't graph the last one. So we'll say this is -10, -20. Again, my graph isn't going to be beautiful, so we'll try to keep scale here. So we'll say that's about 10. That looks about right. So our launch pad this time is -14. Start with the y-intercept, so something about right here. And we're going to rise 4. That will go to -10 and go over 7. So up 4 over 7. That's about right there, I think. So there is our line. All graphed and nice. Let's do 2 more before we quit today. So let me grab my cursor. And these ones I'm not going to be as careful about making in advance. And the reason for that is I want to show you that in real life lines don't always come out quite so nice. So let's make a line, well, at least one of them. One of them I'm going to make nice again, I guess. Let's make a line that passes through the point -6, 10, and the point -6, 20. Okay, let's do that one. So we'll call this guy example 5. I guess I should add the word through. Alright, so let's do that one, and then let's do one more after we're done with that one. And this one I'm just totally not even going to think about at all, just to prove the point that sometimes answers don't come out real nice with nice integers. So I'm just going to say, I don't know, no, I don't want to think about it too much at all. So I'm going to say through like 3, 10, and I don't know, pick your favorite point if you want to do a different one than me. So let's say -4, I don't know, -9. How about that one? Okay, so the last 2 problems. So if you want, I think a good thing to do would be to pause the video and try these out on your own first. So I'm going to use the same strategies that we've been using so far today in today's lesson. So first we're going to find the slope between these 2 points. So change in y over change in x. That's going to be 20 minus 10 over -6 minus, oh, another -6. Make sure you get all your negatives. So that's -6 plus 6, so that's 10 over 0. I don't think you can divide by 0. I think that's undefined. So how are we going to put something that's undefined up in like either one of these? We can't like stick it in and solve like we've been sticking in these numbers, right? So how are we going to do that? Well, maybe we should just think a little bit more instead of just jumping and trying to pursue techniques. This class will be a lot about thinking as well. We're going to learn techniques, but if you don't think in addition to using the techniques, I think you'll get lost on some problems. So what's special about these 2 points? Is anything weird? Is anything strange? Is anything special about them? I think the thing that's special is that they both go through -6, so really, don't we have 2 points that both go through -6, like -6, 10, and -6, 20, if that's 10 and so forth? What kind of line is that? Well, that's a perfectly vertical line, and a perfectly vertical line doesn't really have a slope because it runs nothing. That's why we got 0 on the bottom here. So if you remember from Algebra 1, that's a kind of a special case. This is the equation of the line x equals 10. Let's add that to our list of things. So in your notes, I would add that up here. A special x equals any number, like, we'll just put a number. That's going to be a vertical line, and it's going to have undefined slope. So you need to make sure you don't mix that up with a horizontal line, which is going to be y equals some number. So you cannot mix these up. I used to always be tempted to mix these up. So the way that you should think about it, well, one way I think about it, but you need to keep it straight for yourself, is that if you have 2 points on a line, as soon as you just plot 2 points, those have the same x value, not the same y value, and that's why it's x equals 10. No matter what, every point on this line has x equals, oh, and it's not 10, what am I doing? Haha, it looks like it's x equals -6, right? That's the equation of that line. So if you plot a couple points on a line and it's horizontal or vertical and you just think about it for a second, you slow down and think about it, I think that you'll usually come up with what that line is right away. So let's say we plotted those 2 points both at -10, then the equation of this line would be y equals -10 because that's the only characteristic that all the points on the line share. Alright, so for our last example today, we're going to make a line that passes through these. So same kind of strategy. First find the slope. Find the change in y's, and put that over the change in the x's. Nope, it's not -3, it's +3. Alright, so I got -19 over -7, so that becomes 19/7. I think that's the best I can do with it. So here you can see, when I just made up the line, it didn't come out with a nice slope. So, well, that's reality. So I'm going to have to go ahead and work with that when I plug in my information. So I'm going to use the positive one, because that's easier. So I'm going to make it go through 310 to find the rest. So y minus, and I'm going to use point slope, of course, y minus y1. And we're going to make that equal to, the slope we found was 19/7. I'm going to plug that in. And I'm going to go x minus the x-coordinate to that point. Alright, so there's the line, but usually if we were going to graph it or do most stuff with it, we'd want it in an mx plus b. So let's distribute, and that's where I think it might get a little bit interesting. So far, the fraction hasn't caused any issues. I think it's only going to be kind of a pain in one spot. So 19/7 x, that's pretty simple. And then we've got to go and distribute it to that 3. So it's going to be negative 19 over 7 times 3, and that's a little bit messy. So let's go ahead and do this though. Got to get better with our fractions this year. We've got a whole year. I wasn't very good at them in Algebra 2. You'll get better if you practice. Anyway, so I'm going to do this in my head. You could use your calculator. So 3 times 19 is going to be just like 3 times 20. I think that's going to be 57. Alright, and the last step is to add 10 to the other side. So let's do that, and we'll finish. So 19/7 x, we've still got our 57/7. Oops, that's pretty bad. There we go, 57/7 plus 10. So I want to turn 10 into sevenths. So I'd really encourage you to start thinking about common denominators like this. How many sevenths go into just one? If you have one whole, how many sevenths go into that? It's kind of like 7 pieces, right? So you'd have a pie cut into 7 pieces. Let's see, 1, 2, they're supposed to be equal, but 1, 2, 3, 4, 5, 6, 7. So that's 7 sevenths in 1. So how many sevenths would be in 10 of these if I drew 10 more circles? Think about how many sevenths you'd have. I think you'd have 7 in each one. So that'd be 7 times 10, which is 70. Start thinking about that, fractions like that, and it will make your life so much easier. So instead of putting 10 down here, I'm going to put 10 converted into sevenths, which we decided was 70 sevenths. And then I'll finally be done. My line will be y equals 19 sevenths for the slope, x, and 70 minus 57 is 13 sevenths. Now this would be a kind of a pain to graph, and I think you've gotten everything you need from this lesson by now anyway. So I hope you found this reinvigorating and that it covered and reviewed lines so that we can become masters at them soon enough. I'll see you next time.